back to my channel, and today I'm going to be talking about the history of physics. This year specifically, I'm going to be talking about astrophysics and cosmology. So what is astrophysics and what is cosmology? Astrophysics is a field that studies the properties of astronomical objects in our universe. It studies them through mathematics and physics. On the other hand, when we have cosmology, cosmology studies the evolution of our universe. And it's trying to understand the Big Bang and all the way to a potential end for our universe. And it also uses mathematics and physics to understand it. Now, how does astrophysics and cosmology relate to the history of physics itself? Of course, they use physics, but how does it relate to the history of physics? Well, to truly understand that, we must talk about the differences between astronomy and astrophysics. Today, astronomy and astrophysics are used pretty interchangeably, and it isn't wrong to use them. So we have astronomy and astrophysics. The more technical term is astrophysics, as it has the word physics itself. And astronomy is also used to describe the same thing as astrophysics today, but astrophysics consists of the word physics itself, and it's a little bit more accurate in describing what we do today. That's essentially what astronomy and astrophysics have in terms of differences in the words. But however, when we consider the differences in the history of astronomy and astrophysics, we have to talk about how physics interfered with both of them. Okay, so astronomy and astrophysics are totally different things. So if we use this technical approach when we're understanding that astrophysics, when we're talking about modern astronomy, and astronomy we're talking about classical astronomy. What I mean by that is when we're saying just astronomy, we're talking about the astronomy of the Greeks and just astronomy when we didn't have physics. When we're talking about astrophysics, we're talking about the astronomy we have today, which uses physics a lot. So as you can see, at the beginning of time, astronomy was purely based on mathematics. So the only thing you could do if you were an astronomer then and didn't have a telescope is you could look at the night sky, you can use mathematics to locate the object, and pretty much that's what you can do. We can't say, oh, this star is made out of this, that's a pulsar, that's a neutron star. We can't say anything like that. All we can say is that this object is located there. Now, how did astronomy start? Well, astronomy started when early civilizations started gazing at the night sky. They started to wonder and ponder, what are these heavenly objects, celestial bodies, and so on and so forth. Then we got interested into astronomy. Now, trigonometry, the study of trigonometry, was invented by astronomers because to triangulate objects and distances, we need trigonometry. So trigonometry is very useful in astronomy. Now, since trigonometry is used in calculus, and calculus today is used in pretty much a lot of fields, it just means that trigonometry is used in a lot of fields too. So astronomy and trigonometry are totally interrelated, and trigonometry is very useful. So that's essentially what early astronomers used to do. Today, we don't have that. So you could describe astronomy as mathematics and observation. A fun fact is that most astronomers were mathematicians, and most mathematicians were astronomers, because if you're a mathematician and you wanted to get into the job of astronomy, all you just have to learn is how to do basic observations and how to use the mathematics for your advantage. When you learned how to do that, you can essentially use astronomy to our advantage. So that's essentially what astronomy is. When we consider modern astronomy or astrophysics, what we're using is mathematics. We're using physics. And we're using observations. And we're using one last thing, technology. So essentially, astronomy back then was trying to describe mathematics and observation, just that. So if you were an astronomer, mathematics and observations were the two things, or two skills, or right now we could even say the two job requirements we need. For astrophysics, on the other hand, we need to know math, physics, we need to know how to use our observation sets, and we need to use technology. So we have to be pretty good at technology. Astrophysicists these days use the language of Python to essentially decode images and so on and so forth. So they use tons of technology and other technological things. So astrophysics and astronomy differ greatly, but today we use them interchangeably. Now, how does physics play a major role in this? Because that's what we're going to talk about. How does physics interfere with astronomy and astrophysics and make the field of astronomy accelerate way better in terms of development? Well, the beginnings of astronomy, as I mentioned, started when civilization started to look at the night sky, which was very, 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 very early. When we talk about physics, the basic intuition for physics and the basic thought process for physics were also developed very, very, very early. However, when we talk about the basic laws of physics and the basic principles of physics, and by the basics, I just mean classical mechanics, those were developed when we have Isaac Newton and Galileo Galilei, which I made a video called The History of Physics on Classical Mechanics. Okay, so if physics and the basic principles of physics arose when we have essentially just Isaac Newton and Galileo Galilei, and the basics of astronomy were laid out very, very, very early and very earlier than physics, then how does physics play a major role? So if we just draw an arrow like this, we have the progress of astronomy. When physics came, it just accelerated in development. See, physics has a lot of basic principles. Physics gained a lot of popularity once Isaac Newton developed physics. Now, Isaac Newton just didn't develop physics. He also developed mathematics. He also developed a specific type of mathematics called calculus. So as you can see, calculus is a very important field, and astronomy is based on purely mathematics and observation. So if we have a new field of mathematics, which was developed by Isaac Newton, to help use in physics, which is calculus, and calculus is very useful, then calculus should have other applications too. So calculus had tons of applications in astronomy. But when more people came, like when quantum mechanics started to develop, electricity and magnetism, the general theory of relativity, we had multiple more things on physics. So the calculus started to apply more and more to astronomy and also more and more to physics. So the principles in physics, which developed very, very fast compared to the astronomy developed pretty slowly at first, and physics, even though it was developed later than astronomy, developed really fast. And then when physics combined with astronomy, so since both of them use calculus, when we take the calculus part of physics and use it to astronomy and the basic principles of physics, we can actually understand astronomy in a better way. And technology is essentially helped us all this way because we have to understand how our galaxy is. So we know our galaxy is a spiral galaxy because of telescopes and modern technology. We couldn't just use that with a basic telescope. We needed like a lot of telescopes and very powerful telescopes. So technology played a major role in the history of physics and astronomy. So as you can see, mathematics is essentially the middleman between physics and astronomy. Since mathematics was developed solely for physics, and mathematics also started having influences in astronomy, since also mathematics helped in physics, we also started using the principles of physics in astronomy too. And this worked and essentially just made astronomy a better field. Now instead of just triangulating distances to stars and other celestial bodies, we can actually understand what those bodies are made out of. And this has turned into the field of astrophysics. So this is essentially how astronomy was just based on mathematics observation, and when there was a new field of mathematics, this was implemented in astronomy and physics, and since it was also implemented on physics, we used some of the principles to astronomy, and now we can use it way better. To even make a little bit more sense, calculus was just mainly used for physics. So as physics developed with calculus, when you use the principles of physics, calculus also spread a little bit more to astronomy itself. So essentially, what made classical astronomy into modern astronomy, as I say it right now, is essentially just calculus and physics. Calculus and physics essentially made this transformation. So that's essentially what astronomy and astrophysics differ from. Astronomy, we just mean mathematics and observation. Astrophysics, we mean technology, observations, physics, and mathematics, etc. So that's essentially the differences between them. Now that we've talked about that, how physics has influenced them, and this goes the same with cosmology. Although cosmology is a little bit more specific, because we're trying to understand the evolution of our universe. Essentially, we now have a better understanding of how physics played a major role in astronomy. Okay, now that we've talked about that, we talked about What is astrophysics, which is abbreviated A.P, and cosmology, the differences between astronomy and astrophysics. So let's talk about the mathematics and physics applied. As I mentioned, we have calculus, trigonometry, and literally all of the mathematics that has been developed. So these are the two basic fundamental types of mathematics we have, but we could also use differential equations, essentially multivariable calculus, and so on and so forth. And all the other subjects are mainly a branch of calculus. And trigonometry is also heavily used in calculus too. So calculus is the main root. Physics, on the other hand, when we consider theoretical cosmology is based a lot on Einstein's general theory of relativity. Since Einstein's general theory of relativity involves partial differential equations, just saying, so differential equations are very hard. Since Einstein's field equations involve essentially differential equations, they are also a branch of calculus, and Einstein's equations are also a part of physics. So I'll just write E, F, E, and then GR for general relativity. All of cosmology and most of cosmology is pretty much using general relativity because Einstein's general theory of relativity is very useful. So as you can see, mathematics and physics applied are used a lot. For example, sometimes you could use optics. Sometimes you could use all the other physics. So astrophysics uses all the other physics that it needs. It uses all the resources, if we could say it in that perspective. But mainly it uses general relativity, Einstein's field equations, trigonometry, calculus, and etc. All the branches of calculus, like differential equations and etc. Okay. Now that we've talked about that, let's talk about Edwin Hubble. Edwin Hubble is an astronomer, and we're using that in the sense that astronomer and astrophysicist are interchangeable. So Edwin Hubble was an astronomer, and he made major influential discoveries on the field of astronomy itself. As you can see, back then when we had Einstein and many other influential scientists were debating on whether the universe was expanding, contracting, or just being stationary. Now, as you can see, there was a lot of problems on this, because we didn't know whether the universe was expanding or not. Edwin Hubble, on the other hand, used observations and mathematics to see that there was a redshift. And in astronomy, redshift is very important. When we have objects going away from you, we get a redshift. And he used this theory to his advantage to prove that the universe is expanding. So not only did Edwin Hubble prove that the universe is expanding, but he also proved that we're not the only galaxy in our universe. Many people thought that the Milky Way galaxy was the only galaxy in our whole universe. He proved that there were multiple galaxies. Now you may be wondering, okay, we pretty much know that the universe is expanding today, and we know that there are multiple galaxies, so why did these two essentially main discoveries make Edwin Hubble a great astronomer and astrophysicist? The reason is because these were all controversial topics at the time. Many people thought the universe was just saying stationary. Some people thought the universe was expanding. He proved using astronomy that the universe is expanding. Many people at the time thought there was only one galaxy. However, there are multiple galaxies. So these were both controversial topics. He also classified galaxies itself. So the classifications of galaxies are all by Edwin Hubble. So as you can see, Edwin Hubble not only proved that the universe is expanding or that there are multiple galaxies, but he also classified galaxies. So he expanded on the subject that there are not only one galaxy, there are multiple galaxies, and to even further prove this thing, he classified those other galaxies. So as you can see, Edwin Hubble is an influential scientist at that time. So as you can see, he proved many controversial topics. Now that we've talked about an astronomer who played a major role in the history of astronomy, we can make this video to an end. If you like this video and if you like this channel, please subscribe to learn more. Thank you.